given to you, the figure is like this. Okay, let me show you. This can be considered a triangle. Okay, the triangle is looking like this, right? And from this, let me name it P A C. Another side, from C, this is vertically drawn, this is R, and this is PC and A are intersecting at Q. Q. And this is another line from Q drawn perpendicular to the line AC, and this point is nothing but B. Now my dear friends, the question is like that: if PA is equal to X, if PA is equal to X, right? This one is X, right? This QB is equal to Z, right? And RC is equal to Y, this part, this length, this is equal to Y, QB is Z, and RC is Y. So my dear friends, into this question we need to prove that 1 by X. To prove, based upon this, what we need to prove, we need to prove that yes, 1 by X plus 1 by Y is giving you 1 by Z. This is our requirement. This is our requirement, my dear friends. So to prove this, what we will do, we will use the concept of similarity over here. So first of all, just divide this entire figure into two portions. Consider the triangle PAC once, right? When you consider the triangle PAC, the figure will be looking like this. P Let me make little smaller. AC, PAC, and this QB line you can just draw it as it is. This is Q. Now my dear friend, here you can see, let me name it, I think it's visible, right? It's QB. So do one thing, consider these two triangles. That means, first of all, the length of PA you are knowing, it's X. QB is Z, and RC is not visible over here. So we are just considering one triangle only. So into this triangle, if you consider the similarity of the two triangles PAC and QBC, this is the QBC triangle, right? So we can see in the triangle PAC and triangle QBC, right? Hope you understand which are the two triangles, the bigger one and the smaller one. You can see this angle is common. This angle C is common angle which is lying in both the triangles PAC and QBC. For the bigger one, you can see triangle. For the bigger triangle, angle PCA is angle C, and for the smaller triangle, angle QCB is also angle C. So we can write angle PCA is equal to angle QCB, both are equal to angle C, right? This is one of the criteria which is fulfilled, that is one of the angle is fulfilled, A. Another one, PA is standing erect, QB is standing erect, so we can see that this angle is 90 degrees. Similarly, into the smaller triangle, this angle is 90 degree, right? So my dear friends, we can write that yes, angle A and angle B, that means angle PAC is equal to angle QBC is equal to what? Tell me. 90 degree. This angle I am saying for the both triangles. Now you can see, my dear friends, this is the another similarity criteria which is proved. This is the another similarity criteria which is proved. This is another angle which is taken as a common thing. So can we say that by angle criteria, similarity criteria, both of these triangles are similar, right? So we can say that by angle similarity, we can say that triangle PAC is similar to triangle QBC, right? Now if these two triangles are similar, then the corresponding ratio of the sides can be taken as, right? So we can write that AC by BC, isn't it? AC by BC here. We can write, if this is, if these two triangles are similar, we can write the ratio of these two sides PA by QB, PA by QB, right, will be equal to AC by BC, isn't it? From this we can write AC by BC is equal to PA by QB. And what is the value of PA by QB? PA is X, you can see, and QB is Z. So from this we can write X by Z. X by Z is the value of AC by BC, right, my dear friends? So this is one of the relation which we have derived. after proving the similarity of the two triangles. Now just see this one, right? This triangle ACR, as we did for the sky blue color of triangles, let us do for this triangle ACR. So we can see if the figure will be like this. This will be A going directly to R. I'm just making a replica of this, nothing more. This is A, R. This will be C. Similarly, this will be QB. Yes, Ubaldo, Erwin Rosas, Caltres. You are right. Perfectly caught. So here what we can see, my dear friends, if we prove the similarity of these two triangles, which two triangles? This triangle and the bigger one. We can see again as we did for this. For the triangle, let me write A QB and triangle ARC. These two triangles can also be proved as right, Ubaldo, perfectly fine. Your wisdom is on the top. So AQB and ARC, for the two triangles, you can see this angle A is common, right? Angle A is common, that means we can see for the triangle AQB, right? For the triangle AQB, we can write angle QAB is equal to angle RAC, because both are same angles, angle A, both are same angle A, right? Now from here you can see the second angle. So this is proving one of the angle in the similarity. To prove the similarity of two triangles, this angle is proved as a common angle. These, for both the triangles, this angle is same. And again, as we did for this triangle, this angle QBA, angle QBA will be equal to angle RCA, this angle, and both are equal to 90. Angle RCA, both are equal to, tell me, 90 degree. So we can see that another similarity criteria is fulfilled, which is the 90 degree angle for both the triangles. So can we say that these two triangles are similar? So we can say that by angle similarity criteria, we can say that triangle AQB is similar to triangle ARC, right? AQB and ARC both are similar. If both are similar, then we can write the ratios, that is, you can see RC, we are knowing the length of RC. This is Y. This is Y. We are knowing the length of QB. This is Z. Right? So we can write that RC by QB, right, for the both triangles, RC by QB will be equal to AC by AB will be equal to AC by AB. Now if we say if AB is a length A and BC is a length B, right, if this is a small a and this is a small b, I'm saying this length only, right, then into this case AC by BC can be written as A plus B by a small b, A plus B, that means this can be written as A plus B divided by AB. AB is A, right? Similarly, here also, into the first similarity, what we have proved, AC by BC can be written as A plus B by BC is a small b, this is a small b, this is a small a, here also this is a small a, this is a small b, right? I'm just copying it. Now this will give you RC by QB. RC is nothing but Y. This is Y by QB. QB is nothing but Z, right, is equal to A plus B by A right. So from here you can see if x by z is a plus b by b, then what is the value of z by x? Z by x will equal to b by a plus b. So this will give you, when you reverse it, you will get the value of z by x as equal to b by a plus b, isn't it? We have just reversed it. Similarly here, if you reverse it, you will get the value of z by y is equal to a by a plus b, right? A by a plus b. Now z by x is b by a plus b, z by y is a by a plus b. When you just add LHS and RHS, just add this equation and this one. Simply I'm saying to add. Then z by x will be added with z by y, right? adding LHS and RHS, right? This will give you Z by X plus Z by Y right is equal to B by A plus B plus this one A by A plus B, because one of the equation is this one, another is this one. So what we did, we just added this equation number 1 and this equation number 2. So let me write adding 1 and 2 to make it more clear, right? So this will give you Z by X of LHS of equation 1 plus Z by Y LHS of equation 2. This will be entire LHS is equal to RHS of equation 1 B by A plus B. Here I've written, and RHS of equation 2, that is A by A plus B. Here I have written. Now when you just take the LCM and add, you will see the RHS becomes B plus A by A plus B divided by A plus B, B plus A divided by A plus B, right? So you can see this will be cancelled out, and this RHS is equal to 1 into the LHS. We have one Z by X plus Z by Y. So when Z is taken as common, we have 1 by X plus 1 by Y, isn't it? And this Z can be brought to the denominator of RHS, then it becomes 1 by Z, right? And this Z will be removed from here. So isn't we have proved what was required, that is 1 by X plus 1 by Y is equal to 1 by Z. This is proved, my dear friends, right? 1 by X plus 1 by Y is equal to 1 by Z. You can just see the LHS and you can see the RHS, right? These two are proved. This is proved, and in this way this question can be solved, my dear friend. Thank you so much for watching. Take care, happy learning. See you into the next class. Bye bye. Yes, take care.